same element. So Gemini Pro against Gemini Pro, all draws. Like I said, Gemini was actually, it's a heck of a tic-tac-toe player, actually. It's not perfect. Opus 4-7, so 30 draws, 18-0 wins, and like, what is this, 2 extra wins. So if it was perfect, it would be all draws. The interesting part here is, you would think that X and O would be equal, that they are in some of the models, deep seek, this is what you'd expect, but you wouldn't expect, like Sonnet here, O won almost every time. And behind the scenes, I was alternating who went first. I tried to do it right, meaning something about the LLM model training made, in this case, O win more often than X, which I think is, it's interesting to me. It's not to my wife. It's probably not to you either. But that's the same thought. So here's my conclusions. There actually wasn't any LLMs that were perfect. So billions of parameters, billions spent, and whether it's fair or not, the conclusion is, hey, if the AI comes for you, whip out that tic-tac-toe board, or if your job is playing tic-tac-toe. Yeah, it's not super fair because I didn't give an opportunity for it to, have a code harness attached. So if it coded the game and made an external call, of course the LA is going to turn back the right answer. This was strictly an API call and mixed token prediction for it. So you can argue whether it's fair or not, but all of them play well. X and O, like I showed you earlier. This is weird that the training data is such that those are not the same. And open routers, LLMs, you notice I didn't have any really free ones on there. I had trouble with open router because of the free ones. It was heavily ranked. Well, Ryan's not in here anymore. I guess Ryan took off, but I didn't have any luck using that. My goal was to use the cheap ones to work it out, and then play the real thing for money. But I had trouble with this. And like we talked about earlier, I also had trouble getting it to produce unique games. So that's why the temperature ended up being higher. And also when you play the perfect player, if the perfect player happens to be going first, I randomize the starting move so we get some more board diversity involved. So that's it. You need questions, or I know it's a goofy thing, but I just feel like the vendors are handing us a white box, an LLM, and there's no way to know what's going on unless you instrument inside there to get some understanding about it. And I'm kind of about that.
I love this approach. People usually have benchmark data sets to compare the performance of different models.
Yes.
And you have TikTok as the metric to do that.
Yes, this is the Stephen Witty tic-tac-toe benchmark.
I want to post it on my LinkedIn. It is so novel that everyone was doing benchmarking on the data sets and you have done on TikTok.
Right.
If you don't mind, I will post it.
Oh, yeah, absolutely. It's not necessarily, if you Google around, there's other people that made the observation that it's a little strange that it's not perfect. So I can't say I was the first one that came up with it, but I do think it's interesting.
Yeah, it's pretty good.
Thanks for letting me speak. Yeah, sure.
Have you thought about moving this on to other games or other?
I did, Zach let me, I did blackjack. I think I did blackjack when you were here. And then blackjack, I actually had it, and I gave it a visual representation of the board with the cards. It had to know the blackjack game rules. It had to be able to recognize all the cards. And it was the LLM was the player, and the test furnace was the dealer. And the LLM's GPT, whatever it was at the time, it played a perfect game of blackjack. It wasn't like this at all. It was perfect. The more games I played, the closer it would approach the theoretical maximum you can get wins on blackjack. So I've done several goofy things.
Should we get those in some meta classes and then all go there?
Should
Have it watched.
It is odd that it does blackjack so well, but not things like this. Yes.
And how long ago was that blackjack? Because that was a long time ago, right? I mean, that was like.
Yeah, I mean, you were in the audience probably. I don't know. We were
Yeah,
meeting
I
down in
was
the
there.
square.
Over.
It did a remarkable job at blackjack. I mean, a stunning job. Not just not until here, the system didn't have to recognize anything on the image. I gave it to it, or the test harness gave it to us, but in the blackjack case, it was doing image decode on top of that. That's pretty impressive. But tic-tac-toe, not so much. It's not a.
So what I'm interested in, you mentioned temperature briefly.
Yes.
And temperature can force randomness.
Yes.
And so, but it's been hard, at least for me, to understand, well, how do you determine the right value for a temperature? You know, you can kind of guess, or you can be like, oh, well, things seem to be going off a little bit. It's hard to know or have data on it. So if you would reduce the temperature, does it actually play better?
I originally, if you look at this, unique games, I was, you know, if you play 10,000 games, it occurred to me, you know, what does it mean really if you really only play 2 games? I mean, so that's why I started tracking. I had the harness start tracking how many unique games were, and I was looking for a way to generate board variety. And when I increased the temperature, the unique games on each round of 50 did increase. And a couple of models I did test, it didn't have any significance on the win-lose rate, at least on a couple of models.
When you say temperature, are you talking about rates?
It's somebody in the audience might have a better definition for me, but my understanding that the higher the temperature, the better the variety in the output.
I think right now, and I might be totally wrong here, but from what I remember, the latest models that are there after, I believe, GPT 4.4 and GPT 4, they have reduced the ability to fluctuate temperature a lot. And I believe for one of the models which we were using, it's a constant. They just assign a value of 1. So even if you want to change it, practically makes no difference. So they are removing or basically taking away the temperature from the users. At least OpenAI is doing. I don't know what the rest.
I think in general, the models that I played with, they wanted to default to dot 2, 1, 0 to 2, or 1 to 2.
Yeah, maybe.
And I also understand that some of the models on Open Router actually goes up not just to 1, but to 2. Now, I didn't play with that part.
And which ones were those models?
I know this because I already told you Claude Code wrote this. When I had to do a code review, it would flag, hey Stephen, you're limited this to 1, but a bunch of the models will go up to 2.
Right.
Okay, that's how I do that.
Yeah, I know that.
Claude said that himself.
Yeah, OpenClaw, the code, Claude Code said that. That was one of the, when I said look for the bugs, it was one of the things it would flag. So you've limited this to 1, and some of the models will to 2.
And did it give any different thing that if you have to, you could have better business or something like that? Was there any?
I didn't explore, well, this was laziness on my part. I wanted something I wanted the GUI to apply to all the models available. I didn't want to behind the scenes have to try to adapt this is an academic project. It's not a thesis.
It's not so innovative, it's such a level, so I'm good with that. I was just hoping you have any insight on that.
I bet if you pull the JavaScript down, you can say change this and let me know tonight.
An easy way to think of temperature, just like a year ago, was creative freedom. So closer to more creative freedom. If you wanted to stick exactly to your prompt, this was really like you could set it like 0.8, and it was a good balance between sticking to your prompt but also exploring different solutions that you can exact prompt. So easy way to think of it is just creative freedom. But a lot of it, especially all the later models and computers, like like what I should say, it's you don't even change it.
I wanted to test the top models across the board. The OpenAI 5.5 Pro, oh my gosh, it would have cost me $100 to test that. I mean, I plugged it in, I was sitting there and watching, whoop, I said, no, we're not going, we're just going to leave this behind.
Stop playing it.
Right. I'm interested if anybody's surprised that LLMs don't play tic-tac-toe all that well. I mean, what do you assume it would have been?
What reasoning level, I mean, especially with like 5.5 and Opus, what reasoning level?
You know, behind the scenes, I can show you the Open Router API feed-in, so it must have been the default. You think if we would have flagged the thought thing up or whatever?
There's a really big numerical difference between 5.5 low and 5.5 X So there is a difference just in the
Yeah.
reasoning of it.
Yeah, no, I didn't explore that. I'll also comment that most of the models that you see that I put up there, they would execute the 50 games, in a few minutes. But I ran across, I don't know which ones they are, I'd have to look at my notes, but some of them took hours.
Yeah.
It would just sit there and think, it would just sit there and delay, and still produce a crappy tic-tac-toe. Still wouldn't pick the, whatever, but at least one of the models, it would run for a couple hours. Thanks for